Good morning students. In this video we are going to learn Unit 3 Fluids subtopic Atmospheric Pressure. Before we go to today's topic, let us recall previous class portions. In previous class we learnt about thrust. What is called thrust? The force acting perpendicular to the surface is called thrust. The SI unit of thrust is Newton. And also we learnt about pressure. What is called pressure? The force per unit area acting on an object concerned is called pressure. We can say thrust on unit area is pressure. The formula for pressure is equal to thrust by area. And then we learnt about factors determining liquid pressure in liquids. Name the factors that determine liquid pressure in liquids: depth, density of the liquid, acceleration due to gravity. So these are the factors that determine the liquid pressure in liquids. What is the formula to find out the pressure in liquid column? P is equal to H rho G. Pressure is equal to H rho G. H is the depth of the liquid, rho is the density, and G is acceleration due to gravity. Now let us go to today's topic, atmospheric pressure. What is called atmosphere of the earth? Earth is surrounded by a layer of air up to a certain height, nearly 300 km, and this layer of air around the earth is called atmosphere of the earth. Earth is surrounded by a layer of air up to certain height. That height is nearly 300 km, and this layer of air is called atmosphere of the earth. And then next topic, atmospheric pressure. What is called atmospheric pressure? Air occupies space and has weight. It also exerts pressure. This pressure is called atmospheric pressure. Air filled with space and also it has weight. It produces pressure. This pressure is called atmospheric pressure. This atmospheric pressure refers as the air pressure at sea level. This atmospheric pressure refers to air pressure at sea level. Next topic, atmospheric pressure acts like a column. How it acts like a column? See this diagram. This diagram shows the sea level. Air pressure and density are higher at sea level because a taller column of air pushes down. And then here mountain. This diagram shows the mountain. Air pressure and density are lower at a high altitude because a shorter column of air pushes down. Here shorter column of air pushes down, and at sea level taller column of air pushes down. So from this diagram we can understand that air gets thinner if the pressure increases. Air gets thinner with increasing altitude, and then atmospheric pressure decreases as we go up in mountains. While we climb up on the mountains, the atmospheric pressure decreases. On the other hand, air gets heavier as we go down below the sea level like mines. The air gets heavier as we go down below the sea mines. Next topic, human lungs is well adapted to breathe at a pressure of sea level 101.3 kilopascal. The level of breathing for human lung is 101.3 kilopascal. Suppose if the pressure falls at greater altitudes, mountain climbers need some special breathing equipments like oxygen cylinders. Likewise, if a person works in mines, there also the pressure is greater that of the sea level. So that person also needed some special equipments for breathing. Measurement of atmospheric pressure. How can we measure the atmospheric pressure? The instrument used to measure atmospheric pressure is called barometer. It is an instrument used to measure atmospheric pressure. Now this barometer was first designed by Italian physicist Torricelli. How can this barometer is used to measure atmospheric pressure? Now let us see. It consists of a long glass tube. See, it is a long glass tube. The one end is closed and then another end is open. And then this tube is filled with mercury and it is turned upside down into a container containing mercury. Now this is done by closing the open end of the mercury filled tube with the thumb. By closing the open end of the mercury filled tube with the thumb and then opening it after immersing it into a trough of mercury. So by closing the open end with our thumb, we have to immerse the glass tube into a trough containing mercury. Now this barometer works by balancing the mercury in the glass tube against the outside air pressure. What is the principle of barometer? It balances the mercury in this glass tube against the outside air pressure, that is against the atmospheric pressure. If the air pressure increases, what happens in the glass tube? If the air pressure increases, it pushes more of the mercury up into the tube. If the air pressure decreases, more of the mercury drains from the tube. If the air pressure increases, the mercury move into the tube. If the air pressure decreases, the mercury drains from the tube. If there is no air, what happens? If there is no air, the space between the mercury and the closed end is vacuum. Now this vacuum cannot produce any pressure. So the level of mercury in the tube provides a precise measure of air pressure, which is called atmospheric pressure. So the level of mercury in this tube gives an accurate measurement of air pressure. It is called as atmospheric pressure. So the barometer works under the balancing of mercury in a glass tube against the atmospheric pressure. If the pressure increases, the mercury moves into the tube. If the pressure decreases, the mercury drains from the tube. If there is no air, if there is no pressure, then the gap between the empty space, that is the gap between the end of the mercury and the closed end, is called as a vacuum. And then this vacuum does not produce any pressure. By using this method, we can measure the atmospheric pressure very accurately. Now this type of instrument can be used in a lab or weather station. On a typical day at sea level, the height of the mercury column is 760 milliliter. Now let us calculate the pressure due to mercury column 760 millimeter into atmospheric pressure. That is, the height of the mercury column is given as 760 milliliter. By using this, we have to calculate the atmospheric pressure. And then the density of the mercury is given as 13,600 kilogram meter minus 3. By using the height value and density value, now we can calculate the pressure. Pressure P is equal to H rho G. The height of the liquid column is 760 milliliter. Convert this milliliter into meter. So 760 into 10 power minus 3 meter. And then rho is the density, 13,600 kilogram meter minus 3. G is acceleration due to gravity, 9.8 ms minus 2. Now when we calculate all this value, we get 1.013 into 10 power 5 Pascal. So what is the value? 1.013 into 10 power 5 Pascal. Now this pressure is called 1 atmospheric pressure. Now there is also another unit called bar used to measure the atmospheric pressure. We already know that 1 atmospheric pressure is equal to 1.013 into 10 power 5 Pascal. 1 bar gives 1 into 10 power 5 Pascal. Now we have to convert this atmospheric pressure and bar. We get 1 atmospheric pressure is equal to 1.013 bar. Now we have to calculate this bar into kilopascal. So the value in kilopascal gives 101.3 kilopascal. So this means that 1 meter square of surface, the force is acting 1.013 kilonewton. Gauge pressure and absolute pressure. Now let us go to the next topic, gauge pressure and absolute pressure. What is called gauge pressure and absolute pressure? When tire pressure and blood pressure are measured using instrument like gauges, they show the pressure over the atmospheric pressure. While we measure the blood pressure, it gives the reading against the atmospheric pressure. Now this absolute pressure is 0, then it is referenced against a perfect vacuum. Suppose if the gauge pressure is 0, it is referenced against the atmospheric pressure. Suppose if the pressure is higher than the atmospheric pressure, how can we calculate the absolute pressure? We can calculate the absolute pressure by adding atmospheric pressure and gauge pressure. For pressure lower than atmospheric pressure, if the pressure is lower than atmospheric pressure, how can we calculate absolute pressure? The difference between atmospheric pressure and gauge pressure. We have seen that liquid column exerts pressure so that the pressure inside the sea will be more. We already know that the liquid column produces pressure, so the pressure inside the sea level will be more. So here the pressure inside the sea level is more than twice than the atmospheric pressure. So the parts of our body, especially blood vessels and soft tissues, cannot withstand this high pressure. So scuba divers always wear a special suit and equipment to protect them. So while a person swimming in a sea, there the pressure will be more, that is the pressure is twice than the atmospheric pressure. So to manage this, they have to wear a special suit. Now in petrol blend, the tire pressure of vehicle is measured in a unit called PSI. What is PSI? Pascal per inch. It is an old system of unit for measuring pressure. Pascal's law. Pascal's principle is named after Blaise Pascal. It was named after by Blaise Pascal, a French mathematician and a physicist. What is Pascal's law? State the Pascal's law. The law states that the external pressure applied in an incompressible liquid, it is transmitted uniformly throughout the liquid. An external pressure applied to an incompressible liquid transmitted uniformly throughout the liquid. See, external pressure is applied. After applying the external pressure, what happens? The liquid transmitted uniformly throughout the liquid. It is called Pascal's law. Now this Pascal's law can be demonstrated with the help of a glass vessel having holes on its surface. Now fill this vessel with water and push the piston. While we push the piston, what happens? The water rushes out the holes in a vessel. Now here the pressure at all the points are same. The pressure at all the holes are same. Now the force applied on the piston exert pressure on water. While we apply the force, it produces the pressure on water. Now this pressure is transmitted throughout equally in all directions. So it works with the help of a glass vessel having holes at its surface. Now while we press the piston produces the pressure. So the pressure is transmitted equally throughout the liquid in all directions. Now this pressure is applied in various machines used in our daily life. Hydraulic press, it is one of the application of Pascal's law. Pascal's law became the basis for one of the important machines ever developed, the hydraulic press. This hydraulic press consists of two cylinders of different cross-sectional area, capital A and small a. And these two cylinders are fitted with the pistons, and the F1 force is applied on a smaller cross-sectional area. So they are fitted with pistons of cross-sectional area, small a and capital A. The object which one we have to lift is kept on a piston that is having a large cross-sectional area A. Now the force F1 is applied on the piston of small cross-sectional area. Now this force produces the pressure. Now this pressure transmitted equally to the large cylinder. Now this pressure produces the force F2, and then the force F2 acts on A, which is more than the force F1. So how it works? The force F1 is produces on a small cylinder. While we press the piston, the force F1 is applied. So the force F1 produces the pressure. This pressure transmitted equally to the large cylinder, and this pressure produces the force F2, and then the force F2 lift the object up. Now the pressure on piston of small area, we have to calculate the pressure on piston on small area is A, and it is given by P is equal to F1 by A1. Consider this equation as first equation. By using Pascal's law, the pressure on large piston of area capital A, it is also same as that of the small piston. So the pressure P is equal to F2 by A2. That is, in theory it is given the pressure is transmitted equally to the larger cylinder. So both the small piston and large piston having the same pressure. So P is equal to F2 by A2. Consider this equation as second equation. By combining equation 1 and 2, we get F1 by A1 is equal to F2 by A2. From this we have to find out F2. So F2 is equal to F1 by A1 into A2. That is F1 into A2 by A1. Since the ratio A2 by A1 is greater than 1, if A2 by A1 is greater than 1, then the force F2 acts on the larger piston is greater than the force F1. That is, F2 is greater than F1 if the ratio A2 by A1 is greater than 1. So the hydraulic system working in this way are known as force multipliers. This is called as a force multipliers. Thank you, students.